Your hands up close are anything but smooth, with peaks and valleys and folds and rifts. There are plenty of hiding places for a virus to stick. So when you put it on your face, there's high chances that you can also get infected by the virus. But there are two extremely simple ways where you can beat the virus on your hand. So one is soap and water and the other is a hand sanitizer. So you would have wondered which is better. The coronavirus that causes COVID-19 is one of the many viruses that has a protective outer layer like this with a lipid bilayer. So these lipids are like pin-shaped molecules whose heads are attracted to water while their tails repulse it. So in a water-rich environment, the lipids form a shell like this, with the heads that attract water on the outside and the repulsive tails on the inside. This shared reaction of the heads and tails to water makes them loosely stick together, and this is called hydrophobic effect. This outer structure of the virus helps the molecular machinery of the virus to easily break through our membranes and hijack our cells. Even though it looks pretty strong, there are a number of weak points in between the virus. So this is where our soap comes in. Soap has quadrillions of molecules called amphiphiles, which look like this. So this is similar to the biological lipid. So the head attracts water and the tails repulse it. So these amphiphiles compete for space within the virus. So they try to stick to the membrane and compete for a space like this to adjust within the shell. So while competing for space within the lipid bilayer, these amphiphiles tend to break the whole membrane down and it comes crashing down. And then they have this ability to make a bubble around every part of the virus that has been broken down. So some around the proteins, around the RNA, around the lipid bilayer, everything has a bubble formed around it. So that is when you wash your hand with water, these bubbles are washed away. Hand sanitizers, on the other hand, work more like an earthquake. So when you surround the virus with water, the hydrophobic effect that exists between the membrane gives them more strength. It strengthens the bonds in between. And it also gives these spike proteins that we know their shape and the strength to hold together. So this makes the virus easily infect us. But when you expose them to a concentration of alcohol like ethanol or isopropanol, which is found in sanitizers, it gives this overall effect like you remove the nails and mortar from a house and then you hit it with an earthquake. So the whole membrane comes crashing down and the spike proteins also crumble. Even though both the approaches are similarly effective in killing the virus, soap and water has two benefits. It helps to wash away the dirt that might hide the virus particles. And more importantly, it is more easier to cover your hands for 20 seconds with soap and water. While on the other hand, with the hand sanitizer, we use it on the go, which is easy in the absence of a sink. Many common colds are caused by rhinoviruses, which have a protein geometric structure called the capsid. Now, these capsid do not have as many weak points as we saw in the lipid membrane. So it is very difficult for the soap amphiphiles to pry on them and to break the membrane apart. So this is where our hand sanitizer comes in, because the spike proteins on the capsid are still very vulnerable to the destabilizing effect that the hand sanitizer has, because the alcohol tends to break down the bonds. So in this case and in similar cases, the hand sanitizer seems to be more effective. Thank you.